So the first thing we're going to talk about is the derivative of a constant. The derivative of a constant is 0. And that makes sense because a constant is a horizontal line. The slope of a horizontal line is 0, so the derivative of a constant is 0. So if I ask you to do this, if I tell you that I have my function g of x is equal to 5, and I want to find g prime of 5, it is 0. And that's because it's a horizontal line. So it makes total sense. At least I think it does. Because the slope of horizontal line is 0. All the time. Every day. Tomorrow. Yesterday. Next week. Last month. A year from now. Okay. The next one is the power rule. You've all had the opportunity to mess around with doing by definition. What the power rule says is if you were given a function f of x, so as an example, f of x is equal to x squared, then the derivative of that function, f prime of x, is going to be the power coming down as a multiplier. So in this case, a power is 2 times my function, my x value, and then I need to drop my power down by 1. So my derivative of this is just going to be 2x.
Why is not x squared? X square root of x. Why is not the square root of x instead?
So do you all remember when so the question was, why isn't that the square root of x? And you all remember this thing? We're loving this thing right here, the limit as h approaches 0 of f of x plus h minus f of x all over h. Do you remember doing that? Do you remember the fun and joy that we had? Do you also remember when you did that, you ended up with something like this, 2x plus h, or 2h possibly? Do y'all remember that? Joy's dropping a power. Always dropping a power. The only time you're going to get the square root, and I'm glad you asked that question, is if I would have gave you this. If I would have said g of x is equal to 3 times x raised to the 3 over 2. Using the same rule, I'm going to bring down g prime is going to be equal to 3, multiplying, bringing down the power, so 3 over 2, and then x to the 3 halves minus 1, which is 1 half. And that's when you're going to see the square root, is when you have a power that is a fraction to begin with, and then you'll see the square root. Does that make sense? Cool. And so if we take a look at our function, our original function f of x is in red, and then the derivative is in blue. Now we talked about the graphs of the derivatives last time, is that when my graph is decreasing in this region, my derivative is below the x-axis. When my function is increasing in this region, my derivative is above the x-axis. Okay? Kind of makes sense. The next theorem is, I can do them individually. So if I have, say, x squared plus x plus 3, I can take the derivative of x squared plus the derivative of x plus the derivative of 3. It allows me to take and look at, because it's addition or subtraction between them, I can do the derivative of each term individually. That's all that is. That's all it is. It's all these lovely rules right here, these theorems. It just says that if I have something that looks like this, f of x is equal to x squared plus 3x plus 1. And I'm asked to do the derivative of this, f prime of x. Then I do the derivative of dx of the first term, the derivative with respect to x of the second term, and the derivative of, with respect to x, of the last term. That's all that theorem says. That's all of those theorems say. That's it. So a whole bunch of writing to just say I can take the derivative of each term individually, whether it's addition between them or multiplication between them. That's it. That's all that is. So a whole bunch of writing. And so the derivative of this is going to be 2x plus 3 plus 0, 2x plus 3. That's the theorem. In all of its glory. The other part says, hey, if I have a constant multiplier, guess what? That constant multiplier is still there. That's all that says. Please don't write all these down. For the love of gophers, don't write these down. It just says I can take each term individually, whether it's addition or subtraction. All right, please find the derivative of these first three with your partners or alone. First two, I'll make them larger. Do the derivatives of the first two, please. Do y'all get the derivative of the first one to be 3, the derivative of the second one to be 5?
Yep.
Yeah? Yes, no? Okay. Please do the next 3. Now, as you're doing the next 3, it is in your benefit to write the square root as x raised to the 1/2. So whenever you see a square root or a cube root, you do want to write it as the equivalent x raised to that fraction. Okay, yes, this one right here. So G prime, what did you do?
So we take the 1/7.
Okay.
By that, by the exponent of x, which is 1/2.
Okay.
And then you multiply that by x to the 1/2 power, because take 1 subtracted from 1/2 is negative 1/2. You multiply those together, you get 1/14 x to the root of x.
So it's negative 1/2 and you brought it down?
Yeah.
Is it okay if I left it as, that looks like an 11, doesn't it? That looks terrible. Is it okay if I leave it like that?
No.
Yeah, absolutely. You can leave it like that. Or you can write it, as Daniel said, the square root of x. That's fine. Yes.
And if we take it a step further, and so we can add the square root in the bottom.
Do you love yourself? If you love yourself, you leave it. If you don't love yourself, you can rationalize. For the love of gophers, don't rationalize. Please, I beg you, don't rationalize.
Wait a minute. I have a question.
Uh-huh.
How did x get down to the denominator from the numerator?
So that we have this rule that says if a is raised to the negative n, this becomes 1 over a to the n, a raised to the positive n.
That makes sense.
Okay. All right. What about this next one? Who would like to walk me through this next one and what they got? H prime of x.
So you multiply the power of 3x to the 7 with 3.
3 times what?
7,
Okay. X raised to the what?
6.
Why? Why is it 6?
Power goes down.
Because the power goes down 1. Then what?
Then you add 2 into 9.
Add 2 plus 9?
No, add 9 into 2.
So,
9 multiplied by 2.
okay. I'm a very literal person.
And x goes down by 1 power, so it just remains like that. And
Okay.
negative 5,
What happened to my x then?
because it goes to the power of 0.
Right. So the other thing that we have is anything to the 0 power is equal to 1, provided that that value is not 0. So that's why that is just a negative 5. Just cleaning this up, I get 21x to the 6th plus 18x minus 5. How was that? Yes?
So we don't do anything with the plus 1.
No, because the derivative of a constant is 0. How was that? Yes?
You want us to write plus C at the end?
Only when we're integrating, which we're in chapter 6 and 5. We're not there yet. Stop. You need to stop.
I just didn't know.
Stop. Okay, so before you do the derivative on this, you want to write it as x raised to the 1/3 plus 1/2 x raised to the 1/2 plus x plus 7. Who would like to walk me through this one?
I could do it.
You already answered. Okay?
So it's 1/3 x to the negative 2/3.
Negative 2/3.
2/3 plus 1/4 x to the negative 1/2 plus 1.
So any questions on that one? Now writing it as positive exponents, it would be 1 over 3 the cube root of x squared plus 1 over 4 square root of x plus 1. How was that one? Is there any questions? Do we have yes, no's, maybes?
In the front, is that 1 over 3?
Yeah, isn't that a really nice 3? Let me see if I can erase that really nice 3. Better? And my handwriting is, I should have been a doctor if my handwriting is so good. No offense to doctors. That's why I didn't become an architect, because my handwriting was atrocious. And back in the day, you actually had to print everything.
It's fine. You
Okay.
to become an engineer. You did math, so.
I did math. I didn't do that. Next one is our product rule. Our product rule says if I am multiplying two things together, then I take the derivative of the first multiplied by the second plus the derivative of the second multiplied by the first. So as an example, if I have, let me see. I need to think of something that makes sense to do it this way. Oh, I know. The square root of x multiplied by x squared plus 1. So here's my function. Using this rule, then this is going to be the derivative with respect to x of the square root of x multiplied by x squared plus 1. And then it's going to be plus the derivative with respect to x of x squared plus 1, square root of x. Doesn't matter which one you do first. But notice that when I'm doing the derivative of this is what I'm doing the derivative of. When I'm doing the derivative, I'm only doing this portion of it. So this is the product rule. I do the derivative of the first factor multiplied by the second factor plus the derivative of my second factor multiplied by my first factor. So this would equal, this part here is going to equal 1/2 x raised to the negative 1/2. Here's my second factor I'm doing nothing with yet. And then plus the derivative of my second factor is just 2x. That's what that equals. And then multiplied by the square root of x. To clean this up, I end up with 1/2 the square root of x multiplied by x squared plus 1. And then plus 2x raised to the 1/2 plus 1, so 3/2. Questions on any of the algebra I did?
Wait, can you just explain how to do 3/2?
So this one, I'm using this rule that says if my bases are the same, a to the m times b to the n, or a to the n, then this is just going to be a to the m plus n. So what I have is x to the 1 multiplied by x to the 1/2, which is x to the 3 over 2. Yes?
Did you need a second? You need an N, not a second M.
Oh, yeah. Let me see if I can erase that. That should be an n. All right. So rules of exponents. Everything you forgot is going to rear their ugly head again. Are any questions on that example? Okay. So there's also, when you have a multiplier out front, it's just going to come along for the ride. You may see this noted as u v prime, u prime v plus v prime u. You may see it noted that way. So you notice that I take the derivative of the first one times the second factor plus the derivative of the second factor times the first factor. Okay? Derivative of uv is u prime v plus v prime u.
I have a question.
Yes?
If you do that, wouldn't you just end up with the same answers to both the things?
So the question was, if I just do it this way, do I end up with the same answers? Well, did I end up with the same values here? Are those two terms the same? This being one term, and this being the other term. Using that same thing, this is u prime v, this is v prime u. So when you're doing the product rule, one of the things that you can do to prevent yourself from getting confused is label what u and v is. So if I come back up to this example, and here's what I had g of x is equal to the square root of x multiplied by x squared plus 1. Take the time to say u is the square root of x. That means u prime is equal to 1 over 1/2 x raised to the negative 1/2. And then you do v is equal to x squared plus 1. V prime is equal to 2x. And that's one way to keep all of your things in line without losing what you're doing, especially when you have 3 multipliers. And that can happen. Right?
Are we going to be doing 3 multipliers?
Of course we are. When we get to division, so it's so much easier if you learn the chain rule first. But if you get to division, then let's go back to our example. Let's have g of x is equal to the square root of x over x squared plus 1. I would recommend that you go ahead and label u, v, and use this formula right here so you don't lose yourself. Label u, label v, and use that formula. It is u prime v minus v prime u all over v squared, where v is in the denominator. Oh yeah, it's delicious. It's better than do it by definition. We can go back to the definition if you'd prefer.
No.
Some people's like, yeah. Most people are like, no. Okay, so going back to this, I'm going to do the same thing. U is my numerator, so that is a square root of x. U prime is equal to 1/2 x raised to the negative 1/2. V is equal to x squared plus 1. V prime is equal to 2x. Now using this formula, which is u prime v minus v prime u all over v squared. So using that formula, I have 1/2 x raised to the negative 1/2. That is my u prime. My v is x squared plus 1. Minus v prime, which is 2x, multiplied by u, which is the square root of x, all over x squared plus 1, the quantity squared.
Can you put brackets over v, u prime, v prime, and v prime, u prime?
Yes. This is the u prime. Okay, so u prime v. This is the v prime. So we have to clean this up algebraically. We'd like to be done, but we can't because I have a complex fraction. What I have right now is I have something that looks like this. I have x squared plus 1 over 2x raised to the 1/2, or the square root of x if you prefer, minus 2x raised to the 3 over 2 all over x squared plus 1, the quantity squared. That's where we are algebraically. You cannot leave your answer that way. So this is where, if you are a god or goddess of algebra, you're going to rock it. If you are forgetting your rules of algebra, then this is an opportunity for you all to learn them again. I'm giving you plenty of opportunity to learn these again. So I need to clear my complex fraction, and I need to multiply by my lowest common denominator of all of my fractions. What is the lowest common denominator of all my fractions?
2x to the power half
this is the only thing that I have to worry about because everything else is over 1. So I'm going to multiply every term by that. So I'm going to multiply this by 2, x to the 1/2. I'm going to multiply this by 2, x to the 1/2, and then in the denominator 2, x to the 1/2. Yes?
So how did you get, I'm a little bit random, how did you get x squared plus 1 over 2x to the 1/2?
How did I get x, this very first term?
Yeah.
Okay. So this very first term came from the fact that I have here, I have 1/2 x raised to the negative 1/2. So in other words, 1/2 times x, 1 divided by 2, x to the 1/2.
Okay. And you just multiply that.
And this is x squared plus 1 over 1. All right. Now I've multiplied everything by my lowest common denominator, and I end up with x squared plus 1. Do you all agree to that? Minus 4. 2 times 2 is 4. I'm going to add the exponents, so I have 3/2 plus 1/2, which is 4/2, which is x squared, over 2x to the 1/2, x squared plus 1 squared, which is equal to, I heard that sigh, negative 3x squared plus 1 over 2x to the 1/2, x squared plus 1 squared. And there is my final answer. So it's not going to be your rules of differentiation that's going to mess you up. It's going to be your algebra. If you don't get it right, it's your algebra. Yes?
How did you get rid of the 2 square root of x? How did that get out of?
Okay. Right here?
Yeah.
So I look through and I see a complex fraction. I see a fraction within a fraction. And because I see a fraction within a fraction, I'm going to multiply every single term in that complex fraction by the lowest common denominator, which happens to be 2x raised to the 1/2. When I do that, here, this and this cancel themselves out. So the denominator on the first term cancels out by my LCD. And then on my second term, I just do 2 times 2, and then I'm adding these exponents. Don't forget to add these exponents. We're going to add those. So I have 3/2 plus 1/2, which is 4/2, or in other words, 2. Okay? And so there's my answer in all of its glory. Are we ready to do these? All right, cool. Here we go. Find the derivatives of the following functions. We'll start out with this one, which is the product rule. I would recommend, if you're struggling with figuring out what's what, is to label u equals 3x, u prime equals v equals x squared plus x, v prime equals. Then it's u prime v plus v prime u. I'll come around and help. The question is, why doesn't this cancel out with this? Let me ask you this. If I have 5 minus 7 over 6 times 5 squared, do I get to do this? Okay. So the question was, can I do it using the d dx? Absolutely. So this is going to be equal to d, the derivative of x, the derivative with respect to x of 3x. So that's equivalent to u prime multiplied by x squared plus x. And then plus the derivative with respect to x of x squared plus x. That's equivalent to v prime. And then multiplied by 3x. Okay, so there it is with the d dx, derivative with respect to x. Either way, how you write it with u and v and u prime v prime, then f prime of x, the derivative, should equal, it's going to be 3x squared plus x, and then plus 2x plus 1 multiplied by 3x. And then you're going to get 3x squared plus 3x plus 6x squared plus 3x. Your final answer should be 9x squared plus 6x. How is that? Is that okay? Cool. There we go. Here's some more. The fun never ends in here. Get your money's worth. So looking at B, u is equal to 5x minus 3. U prime is equal to 5. V, excuse me, V is equal to 2x squared. V prime is equal to 2 times 2 times x, or in other words, 4x. All right? Using the rules, it is u prime v plus, let me do those in different colors actually. It is u prime v minus v prime u all over v squared. Okay? So I have, this is going to be equal to my 5 multiplied by 2x squared, and then plus my 4x multiplied by 5x minus 3 all over 2x squared squared. All right? So in my numerator, and yes, you have to clean these up algebraically, I get 10x squared plus, oh, that should be a minus here. That should be a minus right here. Minus, and then it's going to be minus 20x squared plus 12x all over 4x to the 4th, negative 10x squared plus 12x all over 4x to the 4th. You do have to algebraically clean this up. That means you do need to factor out of the numerator both a 2 and an x. And so your final answer will be negative 5x plus 3, or plus 6, all over 2x to the 3rd. And that is your final answer. You do have to clean these up algebraically. Have a great day.
Where do you leave that up?